Hello, and in this video we'll be talking about Python generators and the yield statement. Thanks for watching, and I hope you find this video useful. Let's dig right into it, okay? Oh, I'm on the wrong screen again. Gotta get this right. Okay. Okay, quick review of intervals and list comprehension, okay? So, yes, intervals. An interval is an object that can be iterated over. Sounds kind of silly, but if you think about it, it's anything that can be really used in a for loop. So, a good example of that would be, I'm going to actually close this. I get distracted because the other window has a picture of me and it's too distracting. Okay, good example would be lists, strings, tuples, this kind of thing you can do a for loop. So you go one after another. Those are intervals. And, intervals go beyond just lists and tuples and like more common stuff into more interesting intervals. If you go into the iter tools, actually just made or I'm gonna have to redo that video. That's right, I messed that one up. I've got a video that will be coming out about iter tools and all those kinds of cool intervals that you can generate. Yes. So let's go over what a for loop is. So we've got a list here of data, so 0, 1, 2, 3, 4, and we can do a for each. And in each pass, it's going to print. So we get the little printout here just to refresh your memory as to what intervals and what the for loop does. List comprehension. This is a little bit more, I don't want to necessarily say exotic, but it is. I mean, yeah, as far as, yeah, it's maybe not as common. So data, a lot more people are afraid of list comprehension than they need to be. So data, so once again, we've got the same list of data objects of numbers from 0 to 4. So here we go. Our result is going to be x times x for x in data, okay? So you could almost see this as being written in reverse, but it's not. I mean, if you actually just say it out, it makes sense. So x times x for x in data. So that says we're going to do this x times x for every x in data. Okay, so it is doing the same thing. Well, it's going to be doing the same thing. So it's each time. So we can see here is that list comprehension. So it's going to make a list. This result is going to be a list of numbers that are basically the square of these guys here. So square of 0 is 0, square of 1 is 1, square of 4 is, square of 2 is 4, square of 3 is 9, and square of 4 is 16. Really wanted to put those, yeah, okay. So that's list comprehension. So hopefully that, hopefully you've encountered that before. Hopefully, this feels good. If not, I mean, leave me some notes in the comments. I can always do a whole video on list comprehension. Actually, maybe I will. Maybe that's a good idea. Okay, and intervals. So another related topic is range. So range, you give it a number, and then it will basically iterate through those for that number, starting with 0. So range 5 is going to give us 0, 1, 2, 3, 4 range. So you can do that for anything. So, yeah, I mean, you can do it. You can do range for any number basically, and it will iterate through those that many times, starting with 0. Ooh, that's all. That's right. So list comprehension with range. We've got a plane. Hopefully that plane doesn't make too much noise. So here we go. X times x for x in range 5. All right, so we just saw that 5 will basically make an iterator of 5 in length. So here we go. 0, 1, 4, 9, 16. Does that make sense? So we're using list comprehension combined with a range. All right. Okay. Generators are functions that allow you to declare a function and have it behave like an iterator. Okay. May seem strange. We'll get there. All right. So here we go. We've got a new generator, and here we go. We've got our friend from before. Remember that list comprehension? That's x times x for x in range 5. All right. Hopefully you got a good grip on it. If not, go back, take a look at it. Once you get a good grip, then we'll move on. All right. So we can actually assign that to new generator, and the new generator we can loop over new generator and get the same effect. Do you see this? All right. Yeah. This is a small step. It's not that big of a deal, but it's one of those fundamental building blocks. Okay, so generators. Unlike a list, a generator can only be used once. Once it's empty, it's empty. There's nothing left in it. So if we were to do this exact code here, so we make the new generator, then we iterate over it, and then we're going to try to iterate over it again, it's empty. Why is it empty? Because range 5, it only had 5 members in it. And we went through it all. Yield is a keyword. It's like return, all right? So here we go. We're going to stick with that squaring thing. So we're defining a generator, and for x in range 5, we're going to yield x times x, all right? Hopefully you're with me. If you're not with me, complain in the comments. Tell me I should slow down or give me some suggestions. All right, so here we go. We get the yield. And so we've got new generator from the generator. Hopefully these names aren't too confusing. I was trying to be as explicit in their names as possible. So just look at this code, and then for each new generator, we're going to print. All right. So every time we loop over this new generator, it essentially is doing this for loop. So every time we loop over this generator, it's doing this for loop and yielding this x times x, as we can see here. So really, all these are just different ways of getting to the same place. Okay, yield. Each time we iterate, oh, hey, look, I jumped ahead my slides again. Each time we iterate over new generator, we step through the function. This is a good example. We're going to step through. So it doesn't necessarily have to be a loop. You can have multiple yield statements. So here we go. We've got multi-yield. And so the first time it's called, we're going to yield hello. The next time it's going to call, it's going to say world. The next time it's exclamation point. The idea of these is that you can stop a function while it's going, right? So each time, here we go. We've got for each in that yield statement, we're going to print each. We're basically suspending this function in between each iteration of that loop. All right. And you can see that here. So for each, so we're going to keep on going through. We're going to keep on iterating through multi-yield until we're done with this function. And essentially that iterator then will be empty. All right. So here we go. Each time. So the first time we run through multi-yield, it's going to say hello. So there's yield hello, and it gets printed out. The next time, yield world, prints out world. The next time, an extra exclamation point. So this function, this multi-yield function, essentially starts and pauses. It starts again. Well, I suppose we should say it starts, it pauses, resumes, and pauses, and then resumes again. Each time yielding a value, but it remembers it's where it is, right? So as we call multi-yield, it remembers, oh, I already did hello, so now my next one is going to be world. Okay, and we can see this once again. There's a new multi-yield. All right, so x equals 5. We're going to yield that the first time we call it. The next time we call it, it's going to be x equals x plus 5. Then we're going to yield that x. The third time, it's going to be the old x squared. All right, then we're going to yield that. So here we go. So it's the same exact thing, except now we're doing a little bit of work in between. Right. So the first time it's going to be 5. Boom, we got 5. The next time, the next yield state, so after we yield this, when we call it again, it's going to go do this and then yield. All right. Next time we call it, it's going to do this math and then yield the answer. Each time it's it's pausing and then waiting for the next time to be iterated over, and then it resumes. Pauses, then once iterated over again, it resumes again. Hopefully my hands are not out of frame. If you try to talk with your hands and you're out of frame, it doesn't work at all. Okay. Why? Why complicate things with these generators and yields? All right. An important concept, like the most important concept probably for generators for you to think about, is that they're lazy. They only work on demand, and therefore they can save memory and CPU. So here we go. I'm just going to get the memory of this. So imagine if we did that list comprehension earlier for 1 million numbers, right? The memory is going to be fairly large. And your system can probably handle that, right? It can probably square 1 million numbers incredibly fast, right? What happens if you do 1 billion, 1 trillion? There's going to be a limit where it's going to take too much memory for that. And granted, the square is a very easy equation. But imagine if we were doing a much more CPU intensive compilation. Imagine if in your list you had an equation that took 1 second per member, and you had 1 million. That's going to take a very long time. With a generator, you can actually get a usable iterator and start iterating over that 1 million numbers almost immediately, because it doesn't do all the work. See, if we did this list comprehension here, it would do that very high CPU intensive function on every member of the list all at once. You wouldn't be able to do anything until it did all 1 million numbers. Whereas a generator, you can fake it. You just do it one at a time. So every time you iterate, we're going to go through and do that CPU intensive calculation. Yes. So hopefully that worked out. And legally, I'm required. Every tutorial about yield and generators has to talk about the Fibonacci sequence, because it's probably the best, simplest example. So hopefully everyone knows Fibonacci. It's a little spiral pattern. There's a cool equation that goes with it. I'm not going to explain that because I would probably mess it up. I understand how the code works. I'm not quite sure when they show those complex equations how that works. Okay, so here we go. Fibonacci. We have a function called Fibonacci. We're going to start with 0, and then next step is 1. So while true, and the reason why we want while true is because we want to continuously iterate over this. There's never going, in the Fibonacci, it's a sequence of numbers and never ends. Like how pi never ends. Like, you know, it can get as small to infinity. The Fibonacci can also grow into infinity. There is no end to the Fibonacci. So we're just going to continuously go through and keep on generating more numbers. So here we go. While true. So you call Fibonacci, it's going to yield A, and then it's going to start doing the math the next time. We're going to save the old value of A. We're going to make B, but then we're going to make A B, and then we're going to make B the old value of A plus B. All right? And that will generate our numbers. And now we're going to loop through that Fibonacci function. So for each in Fibonacci, print each. We're going to break at 20 because, like I said, this is infinite and it would just keep on going. So the break, don't worry about the break. Don't worry about the break. That's just to stop it from going crazy. Like it says, without a break, the loop would be endless. So take a look at this code. You can see how it's going to loop through this code. Oops. All right. Oops. Oh, you know, I don't have an example. I suppose, I mean, anybody, you can just look up this works. You can look up any Fibonacci sequence. So it doesn't really matter what it looks like. But we can, you know, step through it. So each time it's going to, this while is basically going to be a loop. It's going to continuously go through each time you iterate over this for loop. It's entering this again. So it yields A, then does the math. Yields A, then does the math. Yields A, then does the math. continuously. Yes, I might be wrong about the actual sequence, but it really, at least in this framework, it doesn't matter where the work is being done. The answer comes back correct. Okay, so I hope you have enjoyed this quick introduction to a quick guide to generators and yield statements. If there's anything I missed, or if you have any questions, or comments or suggestions, please leave them in the comments. And if you like this video, please hit that like button. And if you want to see more of these Python tutorials, hit the subscribe button. Yeah, I look forward to hearing from any of you. And if there's any videos you'd like to see me do, yeah, leave me a suggestion in the comments. Thank you very much for watching, and have a wonderful day.